Today we talk about solving inverse trig functions, and our first problem asks us to find a value of x where x is between 0 and 360 degrees such that the cosine of its angle is equal to -1. So really what we're asking is what angle has an x value, since we're talking cosine, of -1. Well, I can kind of do this in my head. You should be able to at this point as well. If I have the unit circle and I'm looking for an x value of -1, the only place that's going to happen is over at 180 degrees. So that should be my answer. Now, there's another way to write this that we've already used yesterday called using inverse trig functions. If I want to isolate x, that's the same as saying the inverse cosine of -1 is equal to x. Another way of saying that is the arc cosine of -1. And really, inverse trig functions or arc trig functions, what have you, all they really ask is what angle gives me this value. So in this case, once again, I want to know what angle gives me an x value, since we're talking cosine of 1 of the negative type, and that's 180 degrees. And that's equal to x. So now let's look at another problem. I know, again, I'm looking for an angle value between 0 and 360 degrees where the sine of that angle is equal to -√3/2. So if I were to rewrite this in inverse notation, I would have the inverse sine of -√3/2 is equal to some unknown value of x. Now, since I'm talking about sine, and I probably really shouldn't be using x, I should be using, let's say, theta. We'll use theta instead. So I'm talking about sine. I'm looking on the unit circle for a y value of √3/2 that's negative, which means y negative would be in the third and fourth quadrant. And I'm looking for that angle that has √3/2 as its y coordinate. And they'd both have to be negative. Well, if I know my unit circle as I should, I can answer that pretty quickly. I know that 300 degrees is the guy in the fourth quadrant, and 240 degrees is the guy in the third quadrant, because both are 60 degrees away. Now we could also say -60, but that wouldn't work in the constraints of my problem because it asked for an answer between 0 and 360, so both would be positive. We know that that inverse notation can be written once again like such. We want to now solve for x, where x is between 0 and 360 degrees, such that the inverse secant of 2 is equal to x. Well, secant, we know, is the reciprocal of cosine. So what I'm really asking is, where is the cosine of some angle theta, or x, equal to 1/2, since that's the reciprocal of 2. Well, I know that since cosine is positive, I could have a positive x value in either the first quadrant or the fourth quadrant. So really my angle theta could be here, or it could be here. Now, I need to know what gives me an x value of a half. Well, in the first quadrant, I know that's 60 degrees. Now, if I'm 60 degrees from that axis here, then I must be 60 degrees from that axis here. If I were to start at 360 degrees, which is my positive value, and back up 60, I'm at 300 degrees. And that answers my question. Okay, now we're going to use a calculator to solve the next two problems. So what we'll do is we'll fire that up, and while we're waiting, we'll put that problem into inverse notation. So basically what I'm asking is x equals the inverse cosine of 0.2. This problem's not a big deal at all because we can just go to our calculator and say, all right, I want to know the inverse cosine of 0.2. And as long as I'm in degree mode, I'm all good. So that gets me about 78 degrees. Now, the inverse cosecant is a little bit different because there is no inverse cosecant on my calculator, as you can see right before you. All right. All I really have is sine, cosine, and tangent and its inverses. However, I know that I can rewrite cosecant as a form of sine. So I know cosecant's the reciprocal of sine, so I can then say that sine of some theta value, or x, is equal to 1 over 7.9. Therefore, I can find the inverse sine of 1 over 7.9 and have the cosecant, or the inverse cosecant value. So I'm going to take now, go back to my calculator, ask for the inverse sine of 1 divided by 7.9. I think I got to back that up and delete it. And that's going to give me some value of 7.27 degrees. Let's move forward. This next problem I wouldn't give you a calculator for. You could solve it using a calculator, but we're not going to do that. So in any kind of problem we're asked to evaluate, you always want to deal with what's in parentheses first. So what they want me to do is find the inverse sine of 2/7. And what I'm really looking for is some angle theta. All right. But here's the deal. I don't have a calculator, so I can't pop this in. So there's got to be another way to get this problem done. Well, there is. This is in inverse notation. What if I were to take it out of inverse notation? Then it would look like sine of theta equals 2/7. Because this says the y value of some angle is equal to 2/7. So if I'm asked for the sine of theta, or the y value, it's equivalent to positive 2/7. Now, if I know that the sine of theta is equal to 2/7, then I know I have some relationship to theta and the sides of a triangle. here's some random theta. And we're assuming once again my angle is in the first quadrant. So sine is equal to the opposite over the hypotenuse. Well, here's the opposite of theta, here's the hypotenuse. Using this information, I can now say the following. Notice, I've said that theta is equal to the inverse sine of 2/7. I can make a substitution into my original problem and say, well, what then is the cosine of theta? Once I find the cosine of theta, since I have this information already, I have my value for the cosine of the inverse sine of 2/7. Finding the adjacent value is necessary to find the cosine of theta. So once again, we use Pythagorean. 49 equals 4 plus, we'll call this x squared. So therefore, I have 45 is equal to x squared. And 3 root 5 is equal to x. So if I'm looking for the cosine of theta, I know that the cosine is the adjacent over the hypotenuse, and my adjacent is 3 root 5. My hypotenuse is 7. So what I can now say is the cosine of theta, and I know theta, we substituted for the inverse sine of 2/7, is equal to this 3 root 5 over 7. Let's do another similar example. We want to now find the tangent of the inverse cosine of 4/5. Once again, I'll say, well, I don't like looking at the inverse notation. We're going to say the inverse cosine of some value is equal to some angle. I'll call that angle theta. So now I'm going to make a substitution back in my original problem. Tangent, instead of saying the inverse cosine of 4/5, I'm going to say theta is equal to some unknown value. Well, now I also know that I can change this from inverse notation to the cosine of theta is equal to 4/5. And now I have a triangular relationship once again. Here's my theta value, the adjacent over the hypotenuse, and I look at this and I see I have a 3, 4, 5 triangle. So the y value is 3. Tangent is equal to the opposite over the adjacent, and in this case, that's equal to 3 over 4. So therefore, the tan of the inverse cosine 4/5 is equal to 3/4. Let's keep moving. Another similar example, we know that if we have inverse tan 7 over 24 is equal to some unknown theta, then I can say the tan of theta is equal to 7/24. And substituting the inverse tan function for theta, I can say the secant of theta is equal to some unknown. Well, the secant is just 1 over the cosine. Is equal to some value. And that's what I'm trying to find. So basically, I now have my triangle relationship given my tangent, which is my opposite y, over my adjacent x. I can say I have a 7 for my y value, a 24 for my x value. And again, this is a Pythagorean triple, so that's 7, 24, 25. And I can say that my secant, which is 1 over my cosine value, or in this case, Instead of the adjacent over the hypotenuse, it's the hypotenuse over the adjacent. I have all those values, and I can just say that secant of theta is 25 over 24. One more time, we're going to solve this triangle and find all the missing sides and angles using inverse values. So in doing this, I need to know the small y value, or the side of y. I know that I have a hypotenuse given to me and an angle. So if I'm looking for the opposite in the hypotenuse, that's the sine of theta equals that small case y value over the hypotenuse. And theta in this case is 28 degrees. So we're doing our right triangle trig again and saying y is equal to 50 sine 28. Pretty easy to solve that. If we're asked to find the x value, well then I could take the cosine of 28 equals the adjacent x over the hypotenuse, 55, and thus 55 cosine 28 equals the lowercase x. Now if I want angle x, I just subtract from 90 degrees, and 90 minus 28 gives me that value of 62 degrees, and that basically solves the triangle for me.